Alright, this time we're going to compute a limit. So basically, the definition of limit is we're going to get closer and closer to 3 from both sides. In this one it's fairly simple. We'll start off and then we'll get more complicated as we go. But we want to try and approach 3 and see if there's a problem. So the first thing we do is we look at the limit and I say, where am I going? I'm approaching 3. And then if I have division, usually I don't want division by 0, so that's where we're looking for there to be a problem. And if I put 3 in there, I'm going to get 9 plus 6 is 15 minus 5 times 3, which is 15, so I get 15 minus 15. This is 0. This is what the problem is. When I try to put 3 in there and just compute, I get division by 0 at 3, so this can't happen. So cleverly, what we're going to do at first is we're going to try and factor these polynomials and hope that the discontinuity goes away, because we're approaching 3 but never actually touching 3. So the first thing that we want to do is try to algebraically simplify this and hope that the division by 0 goes away after we do that. So if there's any justice in the world and I'm approaching 3, I'm hoping that these will factor to x minus 3 will be in both of them, and then I can cancel it out. That's what I'm seeing already, because I'm going to 3. I would really like there to be an x minus 3 on the top and the bottom so that they would cancel, and then that would go away. That's exactly what's going to happen for this one. So this is the limit as x approaches 3 of, we can play these games. You can look at the videos on how we factor polynomials, or specifically quadratics, but you can either complete the square or play the little games of what multiplies to give me -6 and adds to give me -1, so that, keeping in mind I want x minus 3 to be one of those, it's going to be x minus 3, x plus 2. On the bottom I ask myself the same thing, what multiplies to give me +6 and adds to give me -5, hoping that one of the factors is x minus 3. And sure enough, I get x minus 3, x minus 2. So that's exactly what it's saying. If you can do some algebra and see this, it will cancel. And then I can actually now, when I re-look at this, I'll rewrite out the limit as x approaches 3 of x plus 2 over x minus 2. Now when I look at this, when I approach 3, I can put 3 in the bottom and the top and nothing goes wrong. So we do that, and I get 3 plus 2 over 3 minus 2, which is 5 over 1 or 5. So this limit was finite and it exists and equals 5.